Okay, in this lecture I'm going to be going over one particular problem, and the problem is to find the node voltages and the power of each source in this circuit. So I have VA, VB, VC, and VD. Have a 20 volt source, a 10 amp source, and a voltage controlled voltage source, which is controlled in the amount of 3 Vx, and Vx is the voltage drop across this 3 ohm resistor. So I have a definition first here, and it's Vx equals VA minus VD. That's equation 1. Then I have a constraint of VA minus VB equals 20. Then I have VB equals VA minus 20. That's equation 2. Then I have a constraint of VC minus VD equals 3Vx. Next, that gives me VC equals 3Vx plus VD, which is equation 3. Then I'm going to take equation number 1 and I'm going to place it into equation 3. That gives me VC equals 3 times VA minus VD plus VD. Next, that gives me VC equals 3VA minus 3VD plus VD. Then that gives me VC equals 3VA minus 2VD, which gives me equation number 4. Next, I have KCL at supernode VA and VB. That gives me VA minus VD over 3 plus VA over 2 plus VB minus VC over 6 minus 10 equals 0. Next, I have VA over 3 minus VD over 3 plus VA over 2 plus VB over 6 minus VC over 6 equals 10. Next, I have 5VA over 6 plus VB over 6 minus VC over 6 minus VD over 3 equals 10. That's equation 5. Next, I'm going to take equation 2 and equation 4 and place it into equation 5. That gives me 5VA over 6 plus VA minus 20 over 6 minus 3VA minus 2VD over 6 minus VD over 3 equals 10. Next, I have 5VA over 6 plus VA over 6 minus 20 over 6 minus 3VA over 6 plus 2VD over 6 minus VD over 3 equals 10. Next, I have VA over 2 equals 40 over 3, and then that gives me VA equals 80 over 3, which is approximately equal to 26.67, and that is my equation number 6. Next, I have KCL at supernode VC and VD. That gives me VC minus VB over 6 plus VC over 4 plus VD minus VA over 3 plus VD over 1 equals 0. Next, that gives me VC over 6 minus VB over 6 plus VC over 4 plus VD over 3 minus VA over 3 plus VD over 1 equals 0. Next, that gives me negative VA over 3 minus VB over 6 plus VC over 6 plus VC over 4 plus VD over 3 plus VD over 1 equals 0. Then that gives me negative VA over 3 minus VB over 6 plus 5VC over 12 plus 4VD over 3 equals 0, and that's equation 7. Next, I'm going to take equation 2 and equation 4 and place it into equation 7. Next, that gives me negative VA over 3 minus VA minus 20 over 6 plus 5 times 3 VA minus 2 VD over 12 plus 4 VD over 3 equals 0. Next, that gives me negative VA over 3 minus VA over 6 plus 20 over 6 plus 5 VA over 4 minus 5 VD over 6 plus 4 VD over 3 equals 0. Next, that gives me 3 VA over 4 plus VD over 2 equals negative 20 over 6. Then that gives me 9 VA plus 6 VD equals negative 40. That's equation 8. Next, I'm going to take equation 6 and I'm going to place it into equation 8. That gives me 9 times 80 over 3 plus 6 VD equals negative 40. Next, I have 6 VD equals negative 40 minus 240. Then that gives me VD equals negative 140 over 3, which is approximately equal to negative 46.67. That's equation 9. So then next I'm going to take equation 6 and place it into equation 2. That gives me VB equals 80 over 3 minus 20, which equals 20 over 3, which is approximately equal to 6.67. Next, I'm going to take equation 6 and equation 9 and place it into equation 4. That gives me VC equals 3 times 80 over 3 minus 2 times negative 140 over 3, which equals 520 over 3, which is approximately equal to 173.33. So, final result summary for voltages. I have VA equals 80 over 3, which is approximately equal to 26.67. VB equals 20 over 3, which is approximately equal to 6.67. VC equals 520 over 3, which is approximately equal to 173.33. VD equals negative 140 over 3, which is approximately equal to negative 46.67. Vx equals VA minus VD, which equals 220 over 3, which is approximately equal to 73.33. And 3Vx equals 220. So for the power of the 20 volt source, KCL at VA gives us VA minus VD over 3 plus VA over 2 plus I 20 volt equals 0. Then 80 over 3 plus 140 over 3 divided by 3 plus 80 over 3 divided by 2 plus I 20 volt equals 0. That gives us 220 over 9 plus 40 over 3 plus I 20 volt equals 0. And I 20 volt equals negative 340 over 9, which is approximately equal to negative 37.78. So the current exits the positive terminal of the 20 volt source, so the source is delivering power and the power expression has a negative sign. This gives us power of 20 volt equals negative I 20 volt V 20 volt, which equals negative 340 over 9 times 20, which equals negative 6800 over 9 watts, which is approximately equal to negative 755.56 watts. So for the power of the dependent voltage source, KCL at VC gives us VC minus VB over 6 plus VC over 4 plus I3VX equals 0. Then that gives us 520 over 3 minus 20 over 3 divided by 6 plus 520 over 3 divided by 4 plus I3VX equals 0. Then that gives us 250 over 9 plus 130 over 3 plus I3VX equals 0. Then that gives us I3VX equals negative 640 over 9, which is approximately equal to negative 71.11. So the current exits the positive terminal of the dependent source, so the source is delivering power and the power expression has a negative sign. So that gives us power of 3Vx equals negative I3Vx V3Vx, which equals negative 640 over 9 times 220, which equals negative 14800 over 9, which is approximately equal to negative 15.64 kilowatts. Next, the power of the current source. At VB, the voltage of the current source is positive. The current source is delivering power and the power expression has a negative sign. So power of IS equals negative IIS VIS equals negative 10 times 20 over 3, which equals negative 200 over 3, which is approximately equal to negative 66.67 watts. So for my simulation results, I have the power of the 20 volt source is negative 755.55. The power of the 3Vx source is negative 15.64 K. The power of the current source is negative 66.67. Then 3Vx equals 220. VA equals 26.67, VB equals 6.67, VC equals 173.33, VD equals negative 46.67, and Vx equals 73.33. So that is it. That is all that I have in this lecture on this circuit problem here. Hopefully this was helpful for you. Thank you for watching and have a nice day.